Okay, hi Zach. Welcome to lesson number 91. This lesson starts on page 378 in your book, and we are going to go over today the multiplicative property of inequality, and we're going to talk about spheres a little bit more. Okay, so this lesson is actually really important because if you had accidentally skipped over this lesson in your book, there are some problems that you'd be like, what the heck? How did they get that? I don't understand how they got that answer. And it is actually crazy important because it's just like a couple little tidbits and you are going to know so much and you're going to get these problems right. It's going to be awesome. Okay, first of all, the only thing flat earthers have to fear is fear itself. Okay, because we're going to talk about spheres today. Okay, sphere itself. Okay, all right, this is going to be great. This is going to be great. Now that's put you in the proper mood for this lesson. Okay, rules for solving inequalities are the same as the rules for solving equations. So remember, equations, of course, just means a problem with an equal sign in it, equation. And inequalities are anything with less than, greater than, less than or equal to, something like that. That's an inequality. So basically, in general, the rules for solving inequalities, when you're solving these kind of problems, are the same as the rules for solving equations, where they have an equal sign. There's one big exception, which we're going to get to, but first let's talk about what's the same. The addition rule is the same. So the addition rule means when you have an inequality, when you have an equation like x is equal to y, if you add something to one side, you can add it to the other side, and it doesn't change the solution. So this rule says the same quantity can be added to both sides of an equation or an inequality without changing the solution set of that equation or inequality. And remember, when it says the same things can be added, it could also be subtracted too, right? So if you have x, let's make it somewhere where you can see. I'll write it here. X is equal to y. What if you add a -2? It's kind of like subtracting 2, right? But it would be, you could do the same thing to both sides. It's not going to change the equation, and it's not going to change the inequality. So if you have x is greater than y, you could add 2 to both sides. Add 2, I'll write it like that. And it doesn't change it, right? Okay, easy peasy. We got it. Let's go on to the next rule. This is the multiplication rule. And notice that it says here positive, meaning positive numbers. All right, so let's go over it. Every term on both sides of an equation or an inequality can be multiplied by the same positive number without changing the solution set of the equation or inequality. What does that mean? If you have x is equal to y, you can change that to 2x. Well, let's do 2x is equal to 2y. And you're going to get the same solution set. So you just multiplied every term by the same positive number. And remember that it has to be every term, not just either side. So if it's like x equals y plus 1, you would have to do 2x equals 2y plus 1 and then multiply that out. So it would be 2y plus 2, right? So you're multiplying every term on both sides of an equation by the same positive number, and you don't change the solution set. Okay, same thing goes for an inequality. So if you have x is greater than 2, let me do this. X is greater than y, then you can do 2x is still going to be greater than 2y. That makes sense. Okay, so when it's positive, you can do the same thing that you can do with an equation. You can do that to an inequality, and it's not going to change the solution set. Okay, here is the one glaring exception. Okay, I put this little bird there because the bird is glaring. Get it? He's glaring. Okay. All right, so the glaring exception is this. When you multiply by a negative number, When you multiply by a negative number, you have to give it this look because it is not going to be the same type of thing as an equation. So if you have just an equation and you multiply everything by a negative number, it doesn't change the solution set. So for example, if you've got 5 equals 2 plus 3, that's true. Okay, now let's multiply every single term by negative 2. So we'll multiply the 5 by negative 2, the 2, let's move this over here, 2 times a negative 2, and then the 3 times a negative 2. Okay, so if we multiply all of that out, we are going to get something that is negative 10 is equal to negative 4 minus 6. And that's still true. Dwight is correct. He is saying that that is still true. So that's true. It works because you're multiplying every term by the same number. We've been doing that. You can do that and it works. But if it is a statement of inequality, so that means just a less than sign, a greater than, or a less than or equal to, or something like that. Something like this. 8 is greater than 5. Is 8 greater than 5? Yes, it's true. Dwight would be saying, this is indeed true. Okay, now let's multiply everything by a negative number. So we multiply this times a negative 2, and we multiply this times a negative 2. Okay, let me move this up. What do we get? We get negative 16 is greater than negative 10. Ooh, think about your number line. Okay, and you've got the 0 here. Negative 10 is going to come first, and then negative 16 is more to the left. That means it's actually less than. So negative 16 is less than negative 10. So what did that do? That's not true. So the dinosaur man, whatever his name is, he's right because we took a true statement, 8 is greater than 5, true, and when we multiplied it by a negative number, we got this statement, which is false. Okay, so it turns out that if you have an inequality, like this. You've got something with a less than or greater than sign, and you multiply everything by a negative number, every term by a negative number. So for example, let's multiply this one by negative 2 and this one by negative 2. What you have to do now, pay attention, this is important, is you have to reverse the sign. If you reverse the sign, then it's going to be true. So negative 2 times 8 is negative 16. I changed the sign already, and this is negative 10. Whoops, 10. Okay, so now that is true. Negative 16 is less than negative 10. So that's the rule that you have to remember. If you multiply by a negative number, you have to reverse the sign on an inequality. Okay, makes sense? That's why, like, that is an important nugget of information. Okay, so this is actually, I'm going to put a thought cloud around it because you have to remember that. Because if you remember that, you'll definitely get some questions right on the SAT that someone else is going to miss, because that's important. Turning that sign upside down? Oh yeah, important stuff. Okay. Important but easy, so we love it, okay? We're going to do an example. Example 91.1, this is on page 379, and it says, graph the solution to this inequality. Okay, the first thing we have to do is solve the inequalities, so it's not negative x on one side. You want it to just be x on one side. Okay, so I'm going to take this, and also they give you the domain. The domain is all real numbers, so that's important. Okay, now, what am I going to do to solve that? I'm going to multiply everything by a -1. So -1 here, and multiply this by -1. Okay, so if I multiply that negative x times a -1, you know, it's funny that they chose to do it that way because I kind of think of it as dividing by a -1 so that then the -1s cancel out like that, and then dividing it like that. But it's the same thing. You get the same answer, so I guess it doesn't matter. I'll just do it the way the book is telling you. So it says multiply by -1 to isolate the x. And then what you get is just an x on this side, and on the right-hand side you get -2. Now, don't forget, what do we do with this sign? We've got to turn it upside down. So x is now less than or equal to -2. I guarantee this is going to be on the AP test. They love this on AP tests because they're going to give you a number line that looks like this, and then you'll probably have lots of choices, and one of the graphs is going to look like that. One of the graphs is going to look like that. One of the graphs is going to look like this, right? And it's so confusing. So if you know how to just multiply by -1, isolate the x, and then graph that, you're going to be way ahead of the game. So how do we graph it? X is less than or equal to -2. Since it includes -2, I put a filled in circle right there, and then it's less than that, so anything to the left, and that's it. That's the answer. We graphed the solution of x is less than or equal to -2. And the domain is all real numbers, so it's anything in between the integers as well. Okay, sweet. Let's do the next example. You've got this now, right? Haha, did you see that? That means I get to hit you, right? That was the game. All right, we're going to graph the solution, 91.2, graph the solution to this. This time the domain is integers, so we're going to remember that it's spaced out as integers. And here's the equation they give us. 4 minus x on the left-hand side, less than or equal to 6. And this is an inequality, so we're going to have to isolate the x. So the first things first, let's subtract 4 from both sides. And you don't have to change this sign at all when you're adding or subtracting. You just do that the same as with inequalities. Okay, so what we have is negative x on this side is less than or equal to 6 minus 4 is 2. So now I'm to here. And now it looks like the sort of the other problem where you have a negative x on the one hand side and a 2 on the other. I'm going to do it the way I kind of thought to do it before, which is divide by -1. Divide by -1, and then you get the coefficients cancel out, right? So then you have x on the left hand side. 2 over -1, of course, is just -2 because it's like -2 over 1, right? And then what do we do with this sign? We have to flip it. So it's like this. Beautiful. All right, we got it. Now all we have to do is graph that. So if we graph it, I didn't draw a number line this time, so I'll draw one real quick. X is greater than or equal to -2. I'll put my 0 here. -1, -2. So what does that look like? It includes the -2, so I'm going to draw a circle there. And it includes everything to the right, but it's only the integers, right? Because the domain was integers. So let's just do this. I'm going to make it more clear with a different color. And then you would keep doing this until I've got to put my arrow closer so I don't have to do as many integers. Okay, sweet. Let's do the next example. The next one is 91.3. Don't fall for the trap. It's a trap. Okay, don't fall for the trap because we're probably going to have to reverse that sign, but we'll see. We'll see if we do or not, right? All right, this is the inequality that they give us. We have -3x plus 4 on the one hand, and then we have 13 on the other hand, and the domain is all real numbers. Okay, so first things first, let's isolate the x. So I'm going to get rid of that 4, minus 4, and then I'm going to have minus 3x is less than or equal to 9. Okay, and now I'm going to divide by -3. Oh, I'm glad I did the other one the same way because they're just trying to trick you that multiplying and dividing is, it's kind of the same thing because I'm basically multiplying by -1/3, right? So it's the same thing. So here the coefficients cancel out. So I've got x on the left-hand side, and on the right-hand side, I've got 9 divided by -3, so that's going to be -3. What do I do with this inequality? I have to remember to flip it. So it now looks like this. X is greater than or equal to -3. So let's graph that. Okay, here's my number line. Here's 0, 1, 2, -3 here. It's going to include -3, so that's going to be a closed circle. And is it to the right or the left? Well, x is greater than or equal to -3, so let me make it a little more clear to see. That is my answer. Sweet. Okay, let's turn the page and move on to a totally different topic. And now we're going to talk about spheres. I was trying to remember what this guy's name was, and I seriously cannot remember its name. Text me if you know the answer. I'm sure you know the answer, but text me and tell me because I forgot this little guy's name, except that he's super cute. Okay, we're going to go over spheres. And remember that a sphere is perfectly round, like a ball. It's not egg-shaped. It's like a perfect baseball or soccer ball or whatever. All the points on the surface of a sphere are the same distance from the center. So you could have made the radius, it looks like I made it here, right? But it could be anywhere from the center of the ball to anywhere on the surface of the ball, and it's the same. So radius is the same. Okay, now, 2 more important equations that you need to know about spheres. The first one is volume. This you must know. So lock this into your brain. Volume is equal to 4/3 pi r cubed. So really, if you want to know the volume of any sphere, all they have to do is give you the radius. And if they give you the radius, because that's the only unknown, right? You know pi is 3.14. You know everything else in that equation. So if somebody gives you the radius and you know that it's a ball or a perfect sphere, you can figure out the volume of that sphere. That's kind of cool, actually. That is kind of cool. If you know the radius, you can figure out the volume, because all you do is you pull this equation out of the recesses of your brain. Okay? There's another thing that you will always know if somebody gives you the radius of a sphere. You can figure out the surface area of that sphere. So that's kind of cool too. If someone gives you the radius, you will pull this equation out of the recesses of your brain. Ooh, that cloud thought actually looks like a little brain. So this is going to be hiding in the recesses of your brain from now on. Surface area is 4 pi r squared. So volume is 4/3 pi r cubed. Surface area is 4 pi r squared. That makes sense to me because a square is like an area. And cubed is going to be units of volume, like milliliters or cubic centimeters or something like that, right? Okay, so let's talk a little bit more about volume first, and then we'll hit surface area, and then you get to do your homework. Okay, the volume of a sphere is exactly 2/3 the volume of the smallest right circular cylinder into which the sphere fits. Okay, this is weird, and it basically says that, yeah, it can prove to you that the volume of a sphere is always 4/3 pi r cubed, but it's not exactly going to prove it to you in this book because that's a little bit beyond what we're doing. But it's going to tell you enough that you can sort of remember it. If you remember that the volume of the sphere, if you take that ball, like let's say it's a tennis ball, and you put it in a cylinder that exactly fits the size of that tennis ball, the volume of the tennis ball is 2/3 the volume of the cylinder. So the volume of a tennis ball is 2/3 the volume of a cylinder. Okay, So how does that help you remember it? Well, maybe it does and maybe it doesn't. But do you remember how to figure out the volume of a cylinder? Okay, the volume of a cylinder is the area of the base times the height. Okay, and if the area of the base, if it exactly fits that tennis ball, take a look at the area of this base. What is it going to be, the area of that base? It's going to be pi r squared, if that tennis ball fits perfectly in it. And what about the height of the cylinder? So what would that be, this distance here, if the tennis ball fits perfectly into it? It would be 2 times the radius, because the ball is sitting in there and there's a radius this way and there's a radius that way, right? So if the cylinder perfectly fits that around that tennis ball, then the area of the base is pi r squared and the height of that cylinder is 2r. And then we know that the volume of the sphere is 2/3 times the volume of that cylinder. Then that sort of derives the equation. So if you could simplify this whole thing, 2/3 times 2 is 4/3, right? So then that would be 4/3 pi r squared times r, and then it would be just pi r cubed. See? You basically just derived it by knowing the volume of a cylinder. So cool. Good luck, right? Okay, so now, do you remember the volume of a sphere? 4/3 pi r cubed. 4/3 pi r cubed. 4/3 pi r cubed. Yeah, you know the volume of a sphere. All right, let's do example 91.4. Find the volume of a sphere whose radius is 3 centimeters. Now, you pull that equation out of your head. Volume is 4/3 pi r cubed. And if you know that equation, you know how to find the volume of a sphere whose radius is 3 centimeters. All we do is we erase radius and we do 3 centimeters cubed. Okay, so now 3 times 3 times 3 times 4/3. Okay, if you do the math on that, this simplifies to 36 pi centimeters cubed. 36 times 3.14 is going to be 113.04 centimeters cubed. So this is your units, and this is what you got. So that's kind of cool, actually, because all they did was tell you that the radius of the sphere is 3 centimeters, and now you know the volume of the sphere. Cool. All right, let's move on to surface area of spheres. Okay, so surface area of spheres, this is on page 381. Whoa, surface area of spheres, that's almost like a tongue twister, like Irish wristwatch. Irish wristwatch. Surface area of spheres. Okay, the book says there's an easy way to remember how to find the surface area of the sphere. And the way it tells you to remember it is basically just to memorize this picture. Okay, so you've got a sphere. And this is a 3-dimensional shape like a tennis ball. Now it's going to cast a shadow, and the shadow is just going to be a 2-dimensional shape. It's flat. And how do you find the area of a flat circle? It's pi r squared. So this is pi r squared, and there's 4 of these. And if you take the surface area of 4 of these shadows and you meld them together, somehow you get the surface area of this cylinder, or not a cylinder, of a ball, a sphere. Okay, so basically, I don't know that this is a great memory aid, but maybe it works for you. It basically says, close your eyes and try to imagine this diagram in your memory. So the surface area of a sphere is the surface area of 4 circles that have the same radius. So 4 circles that have the same radius is going to be pi r squared. So this is 1 pi r squared, this 2 pi r squared, 3 pi r squared, 4 pi r squared. So that's the surface area of a sphere, 4 pi r squared. Okay, hopefully that helps you remember. So a surface area of a sphere is 4 pi r squared. So that's kind of cool too, I think, because all they have to do is give you the radius of a sphere and you can calculate the surface area. Okay, don't be afraid. Remember, fear leads to the dark side, leads to anger, anger leads to hate, hate leads to suffering. No suffering, just surface area. So example 91.5, find the surface area of a sphere whose radius is 4 meters. Okay, easy peasy. If someone says surface area of a sphere, you pull out of the recesses of your brain the formula, 4 pi r squared, because you remembered the 4 circles, the 4 shadows. Okay, so find the surface area of a sphere whose radius is 4 meters. So now, easy peasy, we just erase this radius and put 4 meters there. And it's going to be 4 times 4 times another 4. So it's going to end up being 64 pi, and the units are going to be meters squared. Whoa, that's pretty big. That's a big sphere. Big sphere. All right, so 64 times pi is 64 times 3.14, which is going to be 200.96 meters squared. All righty, easy peasy, right? Okay, we're going to finish strong here because I'm going to remind you of everything we've learned about spheres so far. This is not really a sphere, I guess. The first one is just the circumference. So the circumference of a circle is 2 pi r. What's the area of a circle? Pi r squared. What's the surface area of a sphere? 4 pi r squared. And what's the volume of a sphere? 4/3 pi r cubed. Sweet. Look at all these equations that you know that are like hiding in the recesses of your brain. That is awesome. Now you know all that stuff. And if someone gives you a math problem with a sphere in it, you can be like, I know how to do this. I got this. All right, Zach, have fun doing your math today. Love ya. Bye.